Now we will see some general rules for determining the image, the size of the image, the nature of the image. Here in case of a plane mirror, at whatever distance you are standing, at all the distance your image, the size of the image remains same. But this won't happen in case of a concave and convex mirror. At different distances from the mirror, you will get different size of image and its nature. So the first rule to know where the image will form and what is its size and nature. To know this, we should know these four rules. The first rule is a ray parallel to principal axis, means this ray, right? It is parallel to principal axis. So after reflection, it will pass through the principal focus. That is, after reflection, this ray will pass from the focus in case of a concave mirror. But if we have a convex mirror, this mirror, it's a diverging mirror. So all the rays parallel to principal focus, after reflection, they will diverge. They appear to diverge. Means it seems that they are coming from the focus. See, it appears that they are coming from the focus. Means this ray, after reflection, it is diverging. So it appears that it is coming from the focus. So we can say in case of a convex mirror, the rays to principal axis appear to diverge from the principal focus. Second rule is ray passing through principal focus for a concave mirror, they will emerge parallel to principal axis. That is, this ray when coming from the, that is passing from the principal focus, after reflection it will go parallel. See here in the first case, this ray was parallel. So after reflection it is going from the focus. Now if you do it reverse, then it is passing from focus, after reflection it will go parallel. It's like a ball. If there is a surface, we throw a ball. So when it incident at that point, it will go like this. And if we throw it again in the reverse way at this point, then after reflection it will go like this. So similar thing happens here. If the ray is parallel, it will pass from the focus, and if the ray is passing from the focus, then after reflection it will go parallel. So these two rules are somewhat similar. In case of a convex mirror, if you throw a rays towards the principal focus, right here, like which is directed towards the principal focus of a convex mirror. So if you throw a ray, if you direct a ray towards the principal focus, after reflection it will emerge parallel. So it is similar to case 1 here. If you throw a ray parallel to principal axis, the ray appear to diverge from the principal focus. And here if you throw a ray towards the principal focus, it will go parallel to principal axis. Now, in the third rule, if the ray which is incident at a pole, it will reflect making the same angle with the principal axis. It is similar for both the case. Here, if the ray is incident at this point at the pole, then after reflection at whatever angle it is incident, it will go with the same angle. Similarly, here also, this is our convex mirror. If you incident this ray at this particular angle, after reflection it will make the same angle and it will reflect. Remember, in all these cases the laws of reflection are followed, but here we can clearly observe in this particular situation. So remember this. Now the fourth rule is, if the ray passing through the center of curvature of a concave mirror or directed in the direction of the center of curvature of a convex mirror, after reflection is reflected back along the same path. That is, this is the curvature. So if we throw a ray from the center, then after reflection it will again move back in the same direction. Similarly, in case of a convex mirror, if we direct a ray towards the center of curvature, so it will go back in the same path, right? Because the center makes an angle 90. Here at all the point on the circle, the center makes an angle 90. So when a ray is incident at a 90 degree on any surface, after reflection it will move back with the same angle. So here also, if you draw a line, imaginary line from the center, then it will make here angle 90, and similarly it will also make here an angle 90. So if the ray is coming at the 90 degree, so after it will reflect back with the same angle 90. So these are the terminology that we will use to obtain image. Remember, we have to use only two rules to get the image. So here we will see the first case, how to obtain image if the object is at infinity. Infinity means at a very large distance, right? If the mirror is a small, then the distance of 200 meter or 500 meter is infinity for that mirror. So here in the first case, the position of the object at infinity, that is, if we try to obtain the image of the sun, here we have a concave mirror and here we have a paper. So we have kept this mirror towards the sun. So all the rays from the sun are coming parallel. Remember, the rays coming from an object which is at very far distance, we have to assume that these rays are parallel. So all the parallel rays after reflection will get focused at a principal focus, will get converged. So here in the second picture also you can assume that the rays from the sun are coming parallel to principal axis. So after reflection they will get focused, they will get converged at a particular point, right? So where the image is obtained, the image is obtained at principal focus. What is the nature? Nature is the real and inverted. Means if your object is like this, then the image will be inverted. And why it is real? Real because it is obtained in the real world. Here this is the point where the image of the sun is obtained. Actually the diameter of the sun is 15 lakh kilometer, but we obtain its image like a point. So we can say the size of the image is highly diminished, point like. And we have obtained the real image, we have obtained the image of the sun on this paper, and this paper is in the real world. So this image is called real image. And when the rays from the sun get focused on this paper, the paper starts burning. Similarly, we are using solar cooker, right? So in the solar cooker, when we place it facing the sun, then the rays from the sun will get focused on the vessel and the vessel gets heated, and due to this we can cook our food also. So this same kind of principle is used in the solar furnace and solar cookers. Now let's see the second case. In the second case, we will keep our object between infinity, right, and center of curvature. That is, we can say beyond center of curvature. This is the center of curvature of our mirror. This is our actual mirror, right? This is our actual sphere and its center is here. So this center is called center of curvature. So we have placed our object beyond center of curvature. So we use only two rays. We can use any rays, right? We have 4 number of rays, but we will use only 2 rays. So here this is our object placed beyond center of curvature. Our object, one ray. See, if there is an actual object, then the rays coming in all the direction, infinite number of rays are coming. But to get an image, we can use any 2 rays. So here the first rule was, when the ray is parallel to principal axis, it passes from the principal focus, and the rays which is passing from the center of curvature, after reflection it will reflect in the same direction. So here this is our incident ray and this is our reflected ray. This is our incident ray and here reflected ray. So when these two rays, this ray and this ray, when they meet here, we will obtain an image. So the image form between, where the image is obtained, between the center of curvature and the principal focus. Here I have done an experiment at my home and obtained an image for you. You can see here I have mirror in my hand, this mirror is a concave mirror, and this mirror is also a concave mirror. And here you can see the windows. Some of the rays are coming from the windows, and that rays I have focused on my walls. You can see the picture on my walls clearly, right? You can see here there are houses, right? So this case is similar to the case 2. Here you can clearly observe the house. The image of the house is obtained on the walls, it is obtained on this screen, and the images that can be obtained on this screen are called real image. I can touch that image, right? Similarly here also. So this is similar to our case. This is right. So when the rays like this also, here we have a candle. So one ray is coming parallel to principal focus. So after reflection, it will pass the rays coming from the coming parallel to principal axis, and after reflection it will pass from the principal focus. Similarly, when the ray is passing from the principal focus, after reflection it is parallel, which is rule number 2. So here these two rays are meeting, and at that point we will get an image. So we can use any of 4 rule. If I want to use here 4 rule, we can use, but we can use any 2. Suppose I want to use all the rule. So this is my object. One ray is parallel, rule number 1. So parallel ray pass from the focus. Ray passing from the center of curvature, after reflection it will trace back the same path. If the ray is passing from the principal focus, after reflection it will go parallel, and the ray making some angle at the pole, it will reflect and emerge here. So all these rays will get focused here, and we obtain the image. So any of the 2 rule we can use. If you see here in this diagram, in this particular diagram, I have used rule number 1 and rule number 4, but here I have used rule number 1 and rule number 2. So any of the 2 rule you can use and obtain the image at the place. Now here something is remaining. Here you can see where was our object, beyond center of curvature, and where is the image, between C and F, that is between center of curvature and principal focus. Nature real and inverted. In the picture also you can see these houses are inverted, right? The house which we have obtained, these all houses are inverted. So here these houses are inverted. Similarly here the image of the candle is inverted and can be obtained on screen. So the nature of the image is real and inverted, and the size of the image compared to object is smaller. So we can say diminished or smaller. So now let's see the third case. So in the third case we will put our object on the, in the first case we have placed it infinity, right? In the second case we have placed it here beyond C. Now that is we are moving towards the mirror. So in the third case object is placed on the C, that is on the center of curvature. So we can use any of the 2 rule, right? Any of the 4 rule, we have to use only 2 rule. So the ray parallel, one ray is passing parallel, so after reflection it will go from the principal focus. Here similarly the ray passing from the principal focus, after reflection it will go parallel. So here 2 rays are meeting, and when the rays meet the image is obtained there. So here the object is placed at the center of curvature, and the image is obtained at the center of curvature at the same place, but the image is inverted. See here candle is upright, but here you can see it is upside down. So the image is inverted, and here if you place a screen at this point, you can obtain this image on this screen, and hence we can say the image is real. So the nature of the image is real and inverted, and the size is same as the object. Here we see if the size of the candle is 5 cm, then the size of the image is also 5 cm. So which rule we have used? The first rule, the ray passing parallel to the principal axis, after reflection it goes from the principal focus, and the another rule, the ray from the principal focus after reflection it goes parallel. So here the reflected rays are meeting. Remember, the image is obtained at a point where the reflected rays are meeting or appear to meet. We cannot obtain the image from the incident ray. We have to obtain the image using the reflected ray. So here in both the case, the reflected rays are meeting at this point. This is our reflected ray and this is also our reflected ray. Now we will move and see our fourth case. Right, so fourth case is the image is placed. In the last case, we have placed the image on the center of curvature. Now we are moving towards the mirror and we will place our object between center of curvature here, between center of curvature and principal focus. So this is our center of curvature and it is the principal focus, and at any point between the center of curvature and focus we have to place our object. So we assume that one ray is going parallel, that is rule number 1. So the parallel rays after reflection will go from the principal focus. So it is going in this direction, right? And a rule, the ray from this point is going like this, right? If you trace back, it is passing from the center of curvature. It is appear that it is passing from the center of curvature. Actually the rays is emerging from this point in the direction of the radius, in the direction of the center of curvature. So it is going like this at this point. So in the rule number 4 we have seen that when the rays are passing from the center of curvature after reflection, they trace back the same path. So this ray which is from the center of curvature and this ray passing from the principal focus, they will meet here, and where the images meet, right, where the rays are meeting, we get the image at that point. So here our object is placed between, here is our center of curvature. So the object is placed between center of curvature and focus, and we have obtained the image which is magnified. So here you can see that the object is placed between center of curvature and focus. The image, the position of the image we obtain beyond center of curvature, that is it is beyond, right? In the case number 2 we have seen that here you can see in the case number 2 the object was beyond center of curvature and the image is between C and F. But in the case number 4 we can see the object is between C and F and the image formed is beyond the center of curvature, right? These both cases are opposite cases. So here you can clearly observe that the image or the object is placed here and its image is obtained beyond center of curvature and which is magnified larger than the object. And if you placed and screen here, you can obtain that image on the screen and hence it is obtained in the real world. So we can say the image is real but also inverted and the size is magnified. Compared to object, the size of the image is larger, hence we can say the size of the image is magnified. Now case number 5. First case, our object was at infinity. Second case, beyond C. Third case, on the C. Fourth case, between C and F. Now in the fifth case, we are again moving towards the center of mirror, that is here. We are moving towards the pole. So now we will place our object on the focus, right, on the principal focus. So here our object is on the principal focus at this point. So we will take any two ray which is passing from the object parallel to principal focus, parallel to principal axis, and after reflection, following the rule number 1, after reflection the ray will pass through the principal focus. And rule number 4, the ray passing from the center of curvature. Here we assume that the rays is passing from the center of curvature like this. It is going in this direction. So after reflection, it will move like this. Hence these rays are parallel. And you all know that the parallel rays never meet. They always go parallel. But we assume that at a very larger distance, that is infinite distance, these rays are meeting. and hence we can say the image is obtained at infinity, that is at a very large distance. So our object is placed at principal focus and the image is at a very large distance at infinity. As it is obtained on screen, right? Because if the mirror is very small, object is very small, then at a distance of 5 or 4 meter compared to object and the mirror, we can say the 5 or 4 meter distance is infinite. Hence if we place a larger screen, we can obtain its image. Hence the image can be obtained in the real world and it is called the real image. And the nature also is inverted. The image is also obtained inverted. And as the size of the object compared to, suppose we assume that the image is obtained here. So the compared to object, the size of the image is highly magnified. So we can say the size of the image is magnified. This kind of situation is used in searchlights, in headlights of the car. How it is used? You have seen in many serials like CID that they have a focusing torch, they have searchlight. So in that case you see here there is a concave mirror inside the torch light. So here this is a concave surface, in between there is a bulb. So here is our bulb and this bulb is placed at the focus, right? So the rays from the focus will go parallel. See here the rays are going parallel. So rays will go parallel to principal focus and you will observe a beam is coming out from this torch. It will never get very smaller. It will get a focused image. You will get a very sharp round circle on the wall because the rays from this get focus at this point because they are going parallel. If they are not going parallel, you will see a very larger circle compared to size of this, but you will see a similar size of the circle on the wall. So this number 5 is used in making torchlights and headlights of the car. Now let's move to case number 6. So here we have placed our image, we have placed our object between. In the last case we have placed the object at F, right? But here we are placing it between pole and focus, that is here between pole and principal focus. So now let's try to imagine where the rays are going and from where the rays are coming out. So here we assume that here the rays from the principal focus, this rays is going, or we can assume that we can assume any of the case, right? We can use any of the rules. So suppose the rule we are using first rule, the ray is going parallel to principal axis. So after reflection it will go from the focus. So next we use rule number 4. The ray is appearing to passing from the center of curvature. We assume that the ray is from the object is going like this and after reflection it is passing from the center of curvature. So these rays are diverging, that is the rays are like this and this diverging ray will never meet. If the rays are going like this, then in the future they will never meet. And when we find this kind of rays, we have to trace back them. We have to draw an imaginary line and we obtain the image behind the mirror. Now you will assume that how can obtain this kind of image. See here in the pictures. Here the man is standing in front of a concave mirror between the pole and the focus, principal focus. He obtained his virtual image behind the mirror, which is very larger than his actual face. Similarly here you can see it is shown with the ray diagram, right? So this kind of images are behind the mirror, and behind the mirror you cannot place screen and take this image on the screen. Hence this kind of images are called virtual image. And you can also see that the image obtained is erect, it is not inverted, right? So the nature of the image is virtual and erect. Here you can also see, right, the size of the image is smaller, the size of the image is larger compared to size of the object. Hence the nature is virtual and erect. Virtual because it is obtained behind the mirror, and erect because it is erect, it is straight, it is upright compared to the object, and also it is magnified. So the size of the image is magnified, and where it is obtained? It is obtained behind the mirror. So this is all about all the cases. In the next slide you can see that all these ray diagram together. So let's have a summary of this. So when we have placed our object at infinity, we have obtained our image at focus. And what was the nature? Inverted and diminished. For the case number 2, the object is beyond center of curvature and we have obtained the image between C and F. So here our image is between center of curvature and principal focus, and we can obtain it on screen. So our image is real and inverted and also diminished because it is smaller compared to object. In case number 3, we have placed our object on curvature and we have also obtained image on the center of curvature. So the size is same and the nature is real and inverted. In the case number 4, we have placed our object between, we are moving towards the mirror. So we have placed it between center of curvature and focus and we obtained the magnified image beyond the center of curvature. So object is between F and C and image is beyond center of curvature, and the nature is real because we can obtain on the screen. It is inverted and it is enlarged. Remember, maximum number of images which are real are always inverted. And in the case number 5, we have placed our object at principal focus. So we have obtained its image at infinite. That is, in the case number 1, we have placed image at infinity. So object is at focus. And if we place the image at object at focus, then its image will be at infinity. Now in the case number 6, we have obtained the virtual image. So in case of a concave mirror, only the one case, that is the case number 6, where we obtain the virtual, enlarged and magnified image. Here we have placed our object between pole and principal focus, and we have obtained our image behind the mirror, and its nature is virtual, enlarged, that is magnified, and erect. Now in the next slide, let's see the use. The concave mirror is used in the shaving mirrors, right, to see the magnified image of the face. In astronomical telescope, in headlights of the car, that we have discussed. In searchlight also we have discussed. In solar furnaces and in dental mirror. So here in this slide you can see that we can use this concave mirror as a dental mirror also, and in the shaving also. Have a nice day.